Hi, I'm Federico Tomassetti, and it's nice for me to be in Munich because, I started playing with MPS in 2010, but I really had the possibility to learn it when I moved in Munich in 2012. Well, Daniel and the people from ITEMIS really spent some time teaching me about MPS, so for me, Munich is the MPS city. Now I work as a consultant in language engineering in Strumenta, this company that I co-founded. And Strumenta means tools in Latin. And today I want to share a few ideas about tool support. Now, from my point of view, DSLs are about capturing ideas, right? You have something in your mind that is maybe a bit abstract, not well defined, and you use a DSLs to formalize and to make it a bit more concrete, something that you can look at and play with. Now, once you have all of your ideas captured and formalized in a way that you can work on, you can add tool support, and in my opinion is at that point that you get value. And why this is the case? Because basically when you have when you are building tool support for your DSLs, you're building tool support for your ideas. So in a way, you can have debuggers for your ideas. Or instead of idea, maybe I could use this German word that Marcus suggested, but but we will need another session to learn how to pronounce that. So I will stick with ideas. So what we are going to see just very shortly a few examples, a debugger, a simulator, a template system. The debugger simulators come from the Elker project, also Marcus talked about. And in this case, what is the value of this debugger, how it works? Well, it permits me to run the application, of course. It's basically a UI for the interpreter that Nico was talking about. But it permits to look at the internal values. So see at one point what are the values of every variable, of every input. Given the language is based on a state machine, I can see in which state I am, which states are reachable, so I can look at the technical details. But I can also see the logs. Obviously, I can see the user has inserted this event with these parameters, and this triggered this transition, and because of this transition, we execute this action. So I can see step by step what is happening. And I can trigger events. It's a state machine-based language, so basically, we look at the models, we see which events are possible in a certain state, and we basically trigger them with all the parameters. Now, one thing that could be interesting is that in this debugger, we can also control the time. So we can say, we can simulate complex interaction with the application. So the patients insert the temperature, then let's pretend 6 hours are passed and insert another value. And this is, of course, something that makes possible to reproduce scenarios that would be extremely complicated to reproduce in the real application, because using the real application, inserting a value, putting the phone on the table and wait 2 days, it's not really an option. So the debugger, we can quickly play with these ideas and verify if our ideas are in agreement with reality. And when there is a conflict, typically reality wins. So maybe you want to figure that out. Now, the same project, the same algorithms, we can also run them in the simulator. The simulator is something that is more easy to use. It's something more intended for people that are less technical. So they can look at something that resembles the real application. So in this case, something that looks like a phone. Of course, they have the image of the phone. They also, in this case, they can manipulate time. You've seen that. Now, what they can do, they can also record the interaction. So we have this button like the VHS recorder. So maybe for younger people, this will not mean much, but for our target user, this means start recording. So when they press this button, they start blinking, of course, because if not, it's... And at that point, it starts recording all the interaction you have with the application. So you insert a value, and someone is writing this down. You move the time forward. Also, this it's written down. And the user can also use this button when we are recording. They're enabled to say, I like what I see, or I do not like what I see. Now, given this simulator is basically an interface for the interpreter, we know at each moment what the user is seeing. So we know that the box that the user is seeing represent a message that has been sent, a recommendation, or represent the fact that the user is in a certain state and can insert certain events. So this very primitive feedback can be translated into assertions, right? So that's easy when the user is happy about what he sees. When he's not happy, he can also just insert a message like, I'm not happy because this recommendation is completely wrong, because I shouldn't be allowed to insert this value at this stage. So it can give feedback in a very easy way. Now, these recordings are saved like tests, so they can be replayed, and they can be executed, and I can also replay in the simulator. I can replay the tests that I recorded, but also tests that I've written manually. So instead of giving to a user a description of the test, so the user insert this value at this time and then wait 2 hours, you can just replay them in the simulator, and you will see the application moving through the screens. Now, what I want to say with this comparison with the debugger and the simulator is that I think this is crucial, the fact that the DSL captures just the insertion and the intention. And the intention is, in this case, the user can insert a value. But it doesn't tell me anything about how I should get this value. And given it doesn't tell me anything about the way to execute this intention, I have the freedom to do that in different ways in the debugger and the simulator. So for different target user, I can have a different implementation and still be satisfying the intention specified in the DSL. The nice thing is that user can just write tests by playing with the application. And basically, there is no training required to use the simulator. I mean, I can understand that some users are less technical, less able to think in a formal way, but it's very hard to find someone that is unable to use something as simple as the simulator, right? Because it just looks like a phone. Another thing is that the simulator can be scripted with CSS and JS. Now, maybe this is not technically exciting, but for someone working in the marketing department, this is very useful because they can write the logic in the DSLs. They can take anyone that knows some CSS and JS, make a nice interface in the simulator, so change the color, add the logo of the client, and they can go and sell it. So that seems a very important point. And that's it about the debugger and the simulator. Now I want to talk about another feature that is very simple, and I've done recently in a project, is just creating support for templates. So the user is just looking at a model, doesn't matter the meaning of this model, also because it's in French anyway. And I can just select the fact that I want to transform this in a template. So we have this context action. I just click the button, make this a template. And I have a very beautiful annotation, my template. At this point, I can take any node and basically through reflection, I see the properties of that node, and I say, okay, I want the name of the node that I've currently selected to become variable, so something that I want to change when I instantiate the template. Now, at this point, I can go through the menu and say I want to instantiate a template. It automatically finds the templates. It sees the properties that becomes variables, and it asks me to insert the new value. And when I instantiate the template, basically I copy the original model, I just change the values. Now, what I like about this feature is that is extremely easy to define, right? If you are over the MPS learning wall, I think it's quite trivial. But still, I think it's an example of something that you can do in MPS that is nice, because with a little effort, you can build these things that is completely generic, because you can use it basically in any language. It works with any properties. You change your languages, it still works, because it just looks by reflection on the properties. It is something that the user were extremely happy about, because permits them to create very complex models and just instantiate variation of them. You could argue that maybe in some case they will need different abstractions. But in this case, I didn't design the language, so it's not my fault. But yeah, but anyway, they really appreciate these things, and I see a very big disconnect between the effort to implement this and the value that they saw in it, because now they feel they have much more freedom to create models very quickly. Yeah. 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 For now, I mean, it was delivered like 1.5 months ago. For now, I didn't hear complaints. I honestly, I thought that was not enough, that they will need, you know, some primitives to get loops or something like this. But apparently they are happy just with the possibility to change the values of the properties. I'm supposed to repeat the question. So when you instantiate the template, is this a copy of the model, or is the model aware of being a template? In instance, no, it's a copy. We basically copy, we adjust the references, because we don't want to have a reference to an element in the original template, but it's basically a copy and it doesn't know anywhere. So if I change the template, it's not aware that the template is changed. Yeah, s- yeah, we will think about that. As I said, I was not involved from the start with this project, but from what I understood, the models have not a long life. Like they build something for a client, they deliver it, and they don't want to change it anymore. But in general, this is a good point to consider. And sure, in some cases, they just will need different abstractions. Other questions? Okay, anyway, I was almost finished. I want just to say that these are just few ideas that came to mind, but we can do a lot of stuff with DSLs, right? We can generate documentation, we can have a very rich support for test generation, like looking at the possible combination of the input parameters and generate tests. We can use the interactive tutorials, also them coming from the embedded platforms. In a project, we've built the possibility to calculate how the complexity of the model evolve over time. You can do a lot of stuff. And the only message that I wanted to give is that, in my opinion, sure, you need to build the right DSL, but that's, for me, it's just what enables you to provide value, and you provide value through tools, because those are the things that user interact with. And DSLs are just the things that permit you to build the tools. And that's all. So if you want to read more, there is my blog on language engineering. And that's it. So thank you.